Okay, I guess we should begin. It's really difficult because I was just in this room previously, so I don't know how many people were also in that session and whether I should make the same joke. I'll see how it goes. Yeah. If I say execute order 66, does that make any sense? It's a bit like being Palpatine in the Star Wars Senate, essentially, is what I'm saying. There's just kind of these crazy bank seats. Not intimidating at all. Right. It went worse the last time, so it's fine. First of all, thank you all very much for coming, and thanks to the organisers for inviting me. This is my first trip to NDC Oslo, although I was at NDC London a little earlier in the year. I've been to Oslo before, beautiful city. You're all very lucky to live here. If you come in the summer, I'm guessing, but that's something else. So today I'm going to be talking about microservices and the inverse Conway manoeuvre. So this is about using organizational units within companies to reason about software development, software systems, and how we can use those structures and use software itself as well to reinforce various key properties that we like about software. So this is my hypothesis, that software boundaries are isomorphic with team boundaries in the limit of Conway's law, and therefore you can use organizational boundaries to reason about cohesion of services, coupling of services, which testing types to apply to services, and which integration patterns we should use between services. It's in very formal language because I did this at the ICWE conference in Lugano a little while back. And there's nothing more scary than a room full of academic computer scientists to make you up your academic language game. So this is my hypothesis, and we'll be exploring this through some examples throughout the rest of this talk. First of all, I should probably introduce myself. So I work for a company called ThoughtWorks. We are a consultancy, so therefore we all look like this. Hell yeah! We are consultants. Seriously, folks, so we're about 4,500 or so now around the world, offices all over the place. In general, what we do for our clients is we solve hard problems for them, generally through building bespoke software, although more and more now we act as advisors to boards around things such as lean product engineering, portfolio management, finance, these sorts of things. So a bit more management consultancy, but all bedded in our roots of bespoke software development. If you've come across us before, if you haven't rather come across us, you may have come across some of our publications or some of the publications that people who have or currently work for us produced on some of the open source software projects that have come from our people. So things like Cruise Control, that was the first ever continuous integration server, Selenium and WebDriver, things like Pico Container, the first IOC container, Go, which is a continuous delivery server, and books, refactoring by our chief scientist, continuous delivery, and more recently, before Sam left to become an independent, Sam Newman's building microservices. All very good, fantastic. Read them all, buy them all. I'm sure those authors will be very happy. Back to me. So I've been at ThoughtWorks about 12 years now. Before that, I spent another 10 or so doing other jobs in industry. I started off as a network engineer, carrying Cat5 crimpers in my back pocket, wearing a tie at a retailer, and big stacks of Microsoft Office 3.5-inch disks that you'd have to sit there for hours. Then I got into actually database development. So I was a database developer for a while on the Oracle platform. Then I moved towards writing software. So I got into C++, then Java. And I guess I'm probably deepest in Java over the years, but I've also spent quite a lot of time on the .NET platform. So C# a couple of years ago. And one of the projects I'll talk about was a C# project. I'm probably best known for this. So I had the dubious honor of defining what microservices are, along with Martin Fowler. There's some debate about the name. I think probably it was Fred George, if you know him. He probably coined the phrase first. We certainly defined this term, for which you can all thank me later. The joke is that we've accidentally created a multi-billion-dollar industry, but we've seen none of it. So, just saying. But for all of you out there selling microservices, just saying. All right. enough of the introductions. So what I'm going to do now is I'm going to talk through what Conway's Law is all about. I'm going to introduce you to Mel Conway. And then I'm going to look at some of the issues that we see in organizations that I see. I mean, I don't know how many organizations I've worked in with ThoughtWorks, but it's probably in the hundreds now. Either as an advisor or writing code or as an architect or whatever it is. And so I've put together a few examples of some of the things I've seen, see if they resonate. And then we'll explore some alternate options and to structuring ourselves to deliver software in accordance maybe with Conway's Law. So this is an excerpt from the original paper that Melvin Conway wrote. So organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Now, in essence, this is an information theory thing. What Melvin Conway is saying is the way we build our software is defined by how we communicate with people on our teams and externally to our teams. And even if we design software differently to how that structure looks, over time our software will look like that structure. And back in whenever it was, 68 it is, isn't it? 1968. This paper was rejected by the Harvard Business Review, and so it sort of, I guess, went off people's radar a bit. It's very difficult here because I can't actually see. Melvin Conway's not in the room, is he? If anyone's sitting next to Melvin Conway, can you just shout? No. Good. Because I've got this theory, right, that Mel Conway is this guy. He's essentially sitting on the balcony, like one of the Muppets, laughing at us. He's there. I told them this in 1968. Look at them down there. Carrying on building their software with their big project teams. Throwing it over the wall. That's basically what Melvin Conway is doing, in my mind. I don't know if he actually is or not. Maybe we'll find out. As I say, his original paper was rejected by HBR, and then some years later there was a joint research project done by them and MIT on Conway's Law. So they took another look at it to see if it was valid or not. They did a huge amount of research, looked at thousands of projects around the world, open source, closed source, different types of systems. And this is what they came up with. This is another excerpt. The paper was with a very snappy title, Exploring the Duality Between Product and Organizational Architectures, a Test of the Mirroring Hypothesis. And what they came up with is highlighted, tightly coupled organizations, even if not an explicit choice, the design naturally becomes tightly coupled, and in loosely coupled organizations, architecture that evolves is more modular over time. So this is what they found, which backed up the original research that Mel Conway, his original hypothesis. So just to reiterate that, tightly coupled organizations, your design will become more tightly coupled. Loosely coupled organizations, architecture will become more modular around those coupling points. And this is kind of okay because some of the properties we want from our software are related to things like cohesion and coupling, right? We want certain parts of our system to be coupled to one another, and we want other parts of our systems to not be coupled to one another. We want loose coupling between components, right? But within components, coupling's okay. If you're talking to a database, or if you need data from somewhere, a database or S3 or wherever it is, some file system somewhere, you better be coupled to the database. Otherwise, how are you going to get the data? And similarly, cohesion. We want parts of our software to be cohesive. We want things to be cohesive around business boundaries, things that are stable, right? So we want cohesive components that are loosely coupled from one another. And this is what Melvin Conway is saying, well, this is what this research supports, is if we organize ourselves in such a way that the teams building those components are loosely coupled from one another, but cohesive, then that's what we'll get. We'll get software that's like that. And that seems like a positive thing. So, back to microservices, Docker, microservices. This is the list of characteristics that Martin and I called out. Now, most people will concentrate, most organizations I've met, concentrate on the first one, so componentization via services. But in our minds, that was only one part of what made up the success of the companies that were using microservices that we talked about in the paper. So the Netflixes, the Guardian newspapers that compare the markets, these organizations. It wasn't just the fact that they wasn't just having small services that was the thing. the other things are as important. And fundamentally, there's this idea of organizing around business capability. What is a business capability? We'll come to that in a sec. So I'm going to be talking for the rest of this around these two characteristics, organized around business capabilities and the idea of running long-lived product teams rather than short-lived project teams. I'm going to cut dead a question I normally get sometime during a microservice talk, which is how big is a microservice? So the definition of the size of a microservice is it has to be small enough to fit in my head. That is a thing. This is called Boyce's Law. Martin Fowler jokes that I should cut my head off and stick it in Paris as an SI unit so that people can measure how big microservices are. And if you've not, it's quite a big head. It's not huge. That's kind of okay. I'm sure there are other bigger heads out there. This comes from a restatement of the single responsibility principle. I was on a project with Dan North, actually, and some others. And we sort of postulated that if you hold your head up to a screen, that should be the maximum size of a class, length of a class, in a reasonable point font, right? If it's any bigger than that, it's too big. It's doing too much. Now, there's another kind of serious point, which is actually if it's bigger than I can understand in one go, if it doesn't fit in my head, it's probably doing too many things, has too many responsibilities. And that's the same with microservices. Right? Microservices should fit in my head. The class or function should fit in my head. And as you chunk up to a module, it should fit in my head. It should have a single responsibility. A microservice should have a single responsibility. Groups of microservices grouped together into bounded contexts should have single responsibilities. They should do one thing. I should be able to understand them. So that's how big a microservice should be. Another way of looking at this, if you're selling them, which our sales guys like to do, is like a normal service is this big, right? Well, a microservice is about that big. Okay, cool. Now I'm done. Okay, moving on. All that. So microservices should be cheap to replace, quick to scale, resilient, and to quote Adrian Copcroft, formerly Netflix, formerly Battery Ventures, and now VP Engineering at AWS, they should allow you to go as fast as possible. That is the goal when we're building services composed of microservices. We want to be able to go as fast as possible. Now, I mentioned I'm going to talk through some of my experiences in the wider world, so I'm going to sort of bring them all together into a set of examples of things I've seen. So a typical company, right? Got lots of examples of this, and hopefully this will resonate. Most organizations, generally because MBAs, have succumbed to this idea of splitting between your business functions and your IT functions. Right, your IT functions tend to be separated out into kind of your development teams, your testing teams, your architects, maybe a PMO, your project managers, and then your business on the other side, commercial colleagues, they tend to be organized around fairly sensible things. They tend to be organized, if you're in retail, you'll have groups of buyers. You'll have buyers for general merchandising. You'll have groups of buyers for women's fashion. You'll have buyers for men's fashion. So on the business side of things, we organize, commercial side of things, we tend to organize around long-lived business capabilities. Meanwhile, in IT, because IT is a cost center often, we organize differently, right? We say we'll group all our functions together. So we'll have DBAs, we'll have ops, we'll have infrastructure people, we'll have developers, testers, etc. So we create artificially these silos because we believe it's, quote, more cost efficient. And that's fine if you're on the side of the scale where you need desperately cost efficiency, right? Now, my experience over the last couple of years is that most sectors, most verticals are undergoing radical change. Radical change. Verticals that I thought were going to be immune from this some years ago, so your insurers, your retail banking and so on, are actually undergoing change faster than retail in some cases. Most verticals are undergoing radical change. And the only way really to avoid being wiped out in many cases is to change the focus of what we do to make us more able to go to keep up with startups that are disrupting our businesses. And the way to do that is to flip from this idea of cost efficiency, so we favor centralization, we favor the idea that we're going to be saving money, towards flow efficiency or value efficiency, so the ability to quickly or more quickly deliver value and quickly pivot over time. So that's what I think is driving many organizations to look at this sort of different ways of organizing themselves. And I'll show you why I think flow efficiency implies that we change the way we structure our organizations. So if you imagine that this is a traditional organization, we're grouped into our traditional silos. We've got ops, we've got architects, and so on. You can visualize this using something called a I've completely forgotten what it's called. It's called a graph of some description, right? So you can essentially, you can group these around the outside of this circle, and you can measure and monitor the dependencies between these teams, right? Where work goes when it hits these teams. It'll come to me in a sec, I'm sure. This is actually not teams. This is an example of doing this for the Spring code base, where you can say each module depends on another module, each module depends on another module. But you can do exactly the same thing for organizations and how work flows around inside organizations. So dependencies of teams on other teams. And what you find in traditional organizations is you get lots of lines, right? You get lots of these chords. Oh, they're called chord diagrams, that's it. Lots of these chords reaching out between these different teams. So you can imagine in this sort of organization how work gets done, what the flow might look like. So, if someone in sales says, I've got this awesome idea for a feature, right? We totally need to build this, or totally need to add this into our product. And so they talk to someone in the project management office, and the project management office says, cool, we'll get a project team together to sort that out for you. Right? By the way, it's going to take us 3 months to get that team together. Come back in 3 months. And they're like, well, okay, fair enough, 3 months. So the project management team gets a team together. First of all, they ask the architects, hey, can you design this thing for us? And the architects say, of course we can design this thing. And they design the thing. Then the architects hand it over to the development teams. And the development teams say, are you having a laugh? Laws of physics, and hand it straight back to the architects. The architects do a bit more work, hand it back to the development teams who do some development. It then gets handed over to testing. Testers do some testing. That's kind of what testers do. And then throw it back because bugs, defects, and you never thought about this, and the users don't like it anyway. And it goes back and forth, until eventually it goes into the queue to be deployed into production. And that queue is, a release train that takes 26 weeks. So you wait another 26 weeks. At which point you've lost all that money that you could have had if you'd optimized your process. That's kind of what these chords represent, work being handed off between different groups in an organization. And this is an example of a sort of traditional sort of model of flow in an organization I visited some years ago now, probably about 8 years ago, and lots and lots of lines everywhere, lots of documents being produced, functional requirements documents. There's a little bit, if I can point without falling off, up there. That's coding. That's where the work's happening. Handoffs, handoffs, handoffs. I like this phrase. It's Dan North's phrase, I believe. He says, the first thing you should do when you're in an organization is you should understand the system of work that you're in. You should be able to understand how work is flowing around your organization. So he's got this mantra, I think it's like visualize. First you visualize, turn the lights on. Then you stabilize, because when you turn the lights on, you realize you're surrounded by tigers. So then you need to work out what to do with the tigers, essentially. And then then afterwards you optimize. So the first thing is this idea of visualizing. And I kind of like this tool called a value stream map for visualizing work. And this is another real example of a value stream map. Names removed to protect, or redacted to protect the innocent. So if you haven't come across value stream maps before, the steps represent value-adding activities. Maybe I'm developing something, I'm designing something, I'm testing something. And the gaps represent wait times. So, and it's essentially, you get this from measuring a piece of work and how it flows through the different stages in your process. So as we can see from this one, value-adding activity, this is actually from a real client. So the middle one was development, so developer writing some code. The first one was design, so some architects designing what the developer was going to do. And the last bit was testing. So of that, you've got 5 days of value-adding activity, right, for a single piece of work. But then you've got this 42 days where the work is sitting somewhere waiting for work to be done on it. So even though only 5 days of work needs to be done in this case, right, and say this piece of work was going to make you $10,000 a day, right, even though only 5 days of work needs to be done, you end up actually with 47 days worth of delay, essentially, or 42 days worth of delay. So you can imagine you've lost all of that money, right? If you could have been making 10 grand a day for 42 days here, if you just optimize what you're doing. And I kind of think of it like a bit like this, right? It's kind of snakes and ladders, right? You move up and then you have to fall back down because you're handing over between different groups. So coming back to our chord diagram, we plot the different relationships between teams and how work moves. There's an interesting thing here because in general, each one of these chords represents a queue in your system. Right? A queue is in computer science queue, except it's full of work, not electrons, I guess. Right? It's full of work. Each of these handoffs represents work moving from one team and going into another team's queue in general. Right? And this is actually why things like self-service from Azure or Amazon or any of the big infrastructure as a service platforms is such a big deal, because there is no queue. You don't have to ask someone from Microsoft to start you a VM. Right? You don't raise a ticket for them to start a VM. Right? You just do it yourself via an API, so self-service. You want to avoid queues if we can, and the reason we want to avoid queues is, and this is, if you haven't come across Don Reinhardson's book, it's massive, incredibly dense, packed with economic theory, but it just blew my mind when I read it. The principles of product development flow, and in that he talks of the effect of queues on systems of work and in computer science, and he says the effect of queues create a number of things. They increase your cycle time, so they increase the amount of time it takes for work to get through that value stream map and into production earning money. Well, obviously, you know, if you've got a big queue and a piece of work comes in, it's got to wait until all the other things are processed in the queue until the work gets done. It also increases your risk the more queues you have. And this is not so obvious, but essentially, the longer a piece of work sits going through these queues, right, the longer the transit time through the entire system, things can change. You know, if you've got a 26-week wait in order to get into production, and after week 12, your competitor has completely blown the opportunity you were looking to take advantage of away, you've not only lost all the effort you've put in, but you've lost more. So it's increases your risk. You also get more variability. So, you know, queues fluctuate in depth, right? So you don't really understand how long things are going to take with any great accuracy. It increased costs, and this is again counterintuitive. They increase cost because you get more overhead, right? So think about governance. I don't know if anyone in the room has got a sort of, you know, I don't know, whatever they're called, sort of architecture review boards or, you know, architecture governance boards, these sorts of things, and they tend to meet every 4 weeks. And, you know, changes, you know, requests to do stuff gets built up for 4 weeks, waiting for the architecture review board to meet, and the architecture review board have got to review 4 weeks worth of stuff, right, which takes a long time. The more stuff you actually have to do and look at, right, the more projects you get, the higher project overhead you get. So they create more overhead. They also decrease quality because you have to wait longer for feedback, and you get higher quality if you get faster feedback, and you get less motivated people. Right? I'm much more motivated if I get to see the results of my effort tomorrow or the end of the week than if it's going to be 26 weeks later. So queues are kind of pernicious. I'm going to go a little bit more deeply into this idea of queuing for a moment. So we've kind of identified a number of, or rather lean people have identified a number of types of waste in systems. Queues are kind of one of them. There are another kind of fairly pernicious set of activities that, or things that reduce our ability to improve flow. The first is the top one. So this is scheduling, having to wait on someone. So I mentioned this with the architecture review boards, that sort of thing. You have to wait for 4 weeks to get your change approved before you can do something, right? Scheduling. Release trains are another one of these. We have to wait for the next release cycle to come around, because it's on a scheduled basis. The next one is queues themselves. You've got different types of queues. This animal is from Dr. Dolittle. It's called a push me, pull you, if you've come across these before. So this is the sort of cyclical queue where a developer finishes a piece of work, puts it into the queue for the QAs to have a look at. The QAs have a look at it, say it's broken, and have to put it back into the queue for the developers to look at. You get these sort of cycles in your organization. And the third one is synchronization. So I have to wait on another team before I can carry on. Lots of different types of waste that you can identify pretty easily just by visualizing your systems using value stream maps. So Peter Drucker, you have to have a management consultancy quote. Peter Drucker says, there's nothing so useless as doing really efficiently something that should not be done at all. So, stuff I've seen. I want to define some terms first. The first one is, what is a capability? I talk about capabilities a lot. So a capability is a combination of processes, people, systems that provide value to a business in some way, and to customers, right? And those customers could be internal, they could be external, right? That capability. It's essentially the stable parts of your business, the what of the business, not the how. Business processes can change and can and should change, right? But the capabilities themselves should be stable. I like to use an example from one of my current clients, who's a retailer, right? So they make stuff in a factory, and in order to make those things in a factory, they need to order raw materials from their suppliers. Now, ordering raw materials is a capability. Unless they shut the factory and decide to stop making things, they're always going to have to be ordering stuff, ordering raw materials. How they order them, that might change. How they're delivered, that might change. The suppliers they use, that might change. But the fact that they need to order things is stable. It's a stable part of the business, and that's where the capability is. So what I see quite a lot is that capabilities are built by large teams. Even if you go down this route, so this is an example from another one of our clients, and they got the idea that we should organize our own capabilities, but they got it subtly wrong. So they had we've got teams in India, we've got a team in London. Team in India is going to be building one capability. In this case, it was selling stuff on the internet. And in London, we're going to build the delivering stuff capability so we can actually ship the things that we're selling, which is fine. They had big groups of people working on this, and they were using projects. So whenever anything needed to be done, the PMO would assign some developers to it. They'd say, okay, so you've got 8 weeks to work on that. You'd spend 8 weeks working on it, and then they'd pop off. They were using this idea of project thinking, short-lived projects rather than product thinking. And so, the project team, the developers would pop into the code base, and they'd pop out again when the project finished. They'd pop into another part of the code base the next time they were asked to look at it, and they'd pop into another part of the code base. And I don't know if you're like me. I mean, I'm a software developer at heart. I'm fundamentally lazy, right? It's why we automate things that whenever we can, right? Because we're fundamentally lazy. And that includes, often, finding shortcuts or the easiest possible path to actually implement a thing. And so the end result with these teams popping into the code base, project finishes, popping out, popping into a different part of the code base, was that they had these capability composed of a massively tangled set of small services, like incredibly tangled, so much so that you had to deploy the whole thing at once, and this is like 50 things. And anytime you made a change to one, you had to make a change the change rippled across all the others, because they were short-lived project teams. This is another example. This kind of is another anti-pattern. This idea of 6 weeks of hardening because I make a change and I don't know how it's going to ripple out to the rest of the organization. Right, so you might work in sprints or iterations, but then fundamentally you've got a 6-week wait. This queue backs up of stuff that needs to get deployed. We need to regression test it. We need to do integration testing on all of it, performance testing. Risk management theater, I heard it called. And there's another one which is quite pernicious, which is having to fan in to test everything together. So we've got lovely build pipelines for each of our different services or systems, but we have to fan in and test everything in an integration environment. And the problem with this, of course, is that the integration environment gets contested, changes overwrite one another, or you have to issue a lock so one team can't deploy because they're waiting on another team. Synchronization, again, another form of waste and wait time. It's this idea of fan-in to end-to-end tests. And similarly, this idea of having to deploy everything all at once. We're so coupled that we're deploying our systems, everything together. So I think Sam called it this, the distributed monolith. Beware the distributed monolith. You're not going as fast as possible in this case. This is simply a recipe for disaster and for people to just be having a nervous breakdown. Coming back to where I was with Conway, Conway's there, he's going, oh, I told you this in 1968. Oh dear. So what might good look like? Does anyone know what this is? I can't see anyone, so shout if you do. Someone said Ebola in the front row. I'm always terrified when people start saying things in the front row because they're always the hardest questions that come from the front row. But that doesn't bode well for the end of this talk. So yes, this is the Ebola virus. And this is a nurse called Pauline Kafeki, who was one of 3 British citizens who went over to Africa to help out with the relief efforts over there and to treat people who'd caught Ebola. She was one of the 3 who caught it herself. So she spent a long time in hospital. She recovered, fortunately. They also found a lot of interesting stuff out about Ebola from her. Things like, even though you think you've got rid of it, it still lives in your eyeballs and things which you can't detect. Very nasty. Anyway, she was at this place called the Royal Free. So the Royal Free is the sort of UK's sort of, I guess, centre of excellence for treating infectious diseases. It's based in London, and she and the other 2 were also there, Ian Crozier and Will Pooley. They were armed forces medics, and they were on detachment. So I was thinking about this, right? I was thinking how, when someone catches an infectious disease as like awful as Ebola, that moves so as quickly as Ebola, in terms of killing you essentially, how do medics actually treat this? Because all 3 of these people survived. How do they go about treating them? And I was thinking about the capabilities that the Royal Free has as a hospital, and it's got a ton of them, right? It's got facilities, pharmacies, it's got the wards, it's got infectious diseases, labs, all these different capabilities. And thinking, if they organise like we do in IT, there would be all these handoffs between people, right? You'd have to be waiting on test results, and if I have to wait 2 days for a blood test to come back, when you could be dead by then, that's kind of not so cool. And then I first came across this idea from Michael Nygaard. So this is something called the OODA loop. This is something that the armed forces use, specifically the Air Force initially, to work out, actually to direct how they build these days, things like fighter jets. But essentially what the OODA loop says is, in a dogfight, the pilots who can navigate this loop, observe, orient, decide, and act fastest, will be the winner in a dogfight. And so, as I say, this has influenced military doctrine, certainly, well, yeah, the Western military doctrine for decades now. There's a guy called Colonel John Boyd who came up with it. So much so that the US Air Force moved away from twin-engine planes towards single-engine, more nimble planes. It's a direct result of the OODA loop. And I was thinking, how do you navigate the OODA loop quickly when you're treating Ebola, right? That's what they need to be doing. They need to be quickly observing, working out what's wrong, deciding and acting. So I read a newspaper article, and it's interesting. And in the newspaper article, it had a list of all the people that were involved in Ebola care in this hospital. And this is that list, you don't need to read them. I've starred the clinicians. So these are the doctors and nurses who are directly caring for the 3 individuals and for Pauline Kafeki. And these stars indicate people who are not in clinical care. So these are facilities people, porters, these are pharmacists, these are cleaners, these are, well, there's actually, who else have we got on here? We've got, people like, engineering people, support services, security, tons of people all involved, right? And actually this is a pretty common thing where you've got, actually the US military, I think it's, in the Marine Corps, for every 1 person on the front line, they're supported by 10 behind them, if you like. So you've got like 1/3 of the people involved in care for Ebola are actually clinicians, but then 2/3 of this big team are supporting them. And this is what Dr. Michael Jacobs, who is leading the care, said. If you imagine all the functions a hospital has to have, not only blah, they all have to be involved. They all have to be specially trained, etc. So, if you look at the Royal Free Hospital capabilities, they don't look like this at all when they're treating infectious diseases. They look like this, right? They get all the people they need in one place to navigate that OODA loop, to provide very quick decision-making, to care for those patients. And this looks fairly similar to stuff we've been talking about for years, right? So this looks like cross-functional teams with a single purpose, focused entirely on patient outcome. And this is what we've been talking about in XP for decades now. It's kind of interesting. Here's another data point back on the waiting or passing work between teams problem. So this is from some research that Thoughtworks did over a number of years on a project in Australia, and they sort of measured cycle time for work items. And they found over a period of time, stories, user stories, work items leaving a team, they cycled an order of magnitude slower than work that could be done within your team. Every time work leaves your team, you're blowing your cycle time by an order of magnitude. We should really think about that, right? Because that's like quite damaging to our ability to get stuff done. So that's one example. And this is true for trauma teams in hospitals. So my sister's an emergency nurse. When a seriously injured trauma patient comes in, they don't. It's not like that patient has to be cycled around the different units in the hospital. They all swarm. All the consultants and specialists swarm to that trauma patient. It's also true in Formula One teams. It's not just the driver, right, on race day or even on training days and test days. It's all of them there, right? All the engineers that are supporting them, and also in the military. So Western military doctrine now, the reinforced battle group is a cross-functional group composed of a number of stable capabilities all together in one place. So you don't get artillery and infantry. You get combined arms forces with all of them together. And they've learned this the hard way. They've learned that this is the best way to organize. Good, James. What about a software existence proof? So, looking at our capabilities again, looking at our functional silos within our organization again, what does it look like if we create cross-functional teams organized around capabilities, lines of business? So I was at an insurance company, actually, with Seb Landor, I don't know if he's in the room, but I was there for a while with him. It was great fun. If you ever get a chance to pair with him, it's awesome. He's the most flamboyant pair programmer I've ever come across. Voila, etc. And in this insurance company, we were helping them break up a big monolithic application. So they had one application, .NET application, VB.NET actually, talking to a SQL Server database that had been ported from DB2 and Kix, I kid you not. So they had this kind of monolithic application, big SQL Server database, and all the products they were selling, insurance products, were inside this one application, all the logic to sell them, all the web pages, etc. Now this insurance company, it was called Compare the Market. They don't mind me talking about them. And so what we advised them to do over a period of time is to say, yeah, you've got your big monolithic thing. Why don't we separate out by your products, right? These are stable things, right? You're always going to be selling these products. Home insurance, or you're going to sell them or not, in which case you can delete them. But organize around your product lines and take the code outside of the monolith and have these separate systems. So that's what they did. They created these different lines of business based around their products. So they created like a home insurance line of business, a motor insurance, a life insurance, and so on. And this is very similar to work we've done. I think there might even be someone in the room who was on this other project at a real estate company in Australia. He's smiling down the front. So this idea that we separate these things out into stable units, organizational units, and then organize your teams around them, it comes directly back to Conway's law, right? Because what we're going to get is a reinforcement of those team boundaries. And of course, you have some cross-cutting concerns as well. So you have these cross-functional teams delivering lines of business, and in this case, any information that needs to come out of those teams in terms of data was done asynchronously via publishing of events. And these dotted lines show that actually Conway's law is going to reinforce the decoupling of these teams and enforce the cohesion of these teams, and therefore the software that they're creating. So cross-functional teams organized around lines of business. Nice. Yay. And so, as a result of that, if we go back to our chord diagram, we can see that we've actually sort of reduced the number of these chords. We haven't got so many handoffs. So we've immediately improved the cycle time. This is actually maths. It's economics. Right? This will make you money just doing this. More money. But I think Melvin Conway, right, he's still up there. Because we've still got a ton of these handoffs. They don't have the ability, those teams, to get work done independently. They're still relying on lots of outside functions in the business. But that's cool, because we can play our DevOps Jez Humble card, right? Woo, DevOps, Docker, Docker, Docker. Are they synonyms yet? I don't know. Well, build it, run it, right? That's what I'm talking about. So at the moment, we've got cross-functional teams, but we've still often got operations that are sitting outside. So great, our cross-functional teams will get all their stuff done, and then they hand it over to another part of the organization who are optimized for stability, and they raise a ticket to say, can you deploy my software? And then they'll have to wait until operations, who are really busy, and I'm not being down on operations at all, right? Operations are really busy usually, right? So they get a work item in their queue, they say, okay, we'll wait until we've got some time, and then we'll deploy your software. Why can't we bring operations with us on this journey and say, actually, we'll build it, run it? So we're going to remove more of these chords from our diagram, more queues, and improve our ability to get stuff done again. Woohoo! So each of these capabilities can be tested and deployed independently, etc. And suddenly, we've got that many queues rather than that many queues. And again, every time work leaves your team, order of magnitude decrease in cycle time. Can we go further, right? This is the next part. So if you imagine all the functions a hospital has to have, they all have to be involved. He didn't say except pharmacy and physical estate. All the functions have to be involved. And at the moment we've got this situation where our commercial colleagues are still nowhere to be seen in terms of our cross-functional build it, run it style teams. So what would it look like if we sort of subsumed our businesses inside our development teams? Or to put it another way, what would it look like if our development teams sat with our business users? Those cross-functional teams building stuff for our business people, why can't they just go and sit with our business people? We don't have IT anymore then. Ooh. All right, that sounds pretty crazy. I spent 5 years or so in investment banks. It's exactly what you do in investment bank front office development. You sit with your commercial colleagues. You sit with the traders on trading desks. That's how IBs make money, because they know the best way to get stuff into production quickly, the best way to deliver value most efficiently, to concentrate on improving flow, is to have people sitting next to one another, talking, just delivering, right? So it doesn't, even though it sounds crazy, and it's certainly not taught on an MBA course that I'm aware of, it actually makes sense, and it is out there in the real world. And you might have seen this called other names. You might have seen this from Spotify. I'm sure you have. This is a similar idea. You have this idea of squads, chapters, guilds. Squads, which are many of which make up a tribe, etc., etc. So the model we've been having quite a lot of success with, this is only one model, is like a concentric, if you like, model of organizational design, rather than a separated model of business or commercial colleagues and IT cost center, commercial making money. And so instead of organizing like that, why don't we organize around the stable elements of our business and actually have our development teams working in those stable elements with our commercial colleagues? So if I'm a buyer in a retailer, there's some developers with me who I can ask, hey, this thing is causing me problems. Can you just do something about it? And we can build a little thing, a little product that will help that person. See, this idea of market segments or organization at the outside, the market segments, the idea of value streams within that, and then the idea of teams within that, with each team owning one or more services. We're back to software. And how big should these units be? Depends on the size of your company. If you're a 10-person startup, you'll probably have one team of 10 people, right? But if you're, the company, a retailer I'm working with at the moment is many, many thousands of people, you need some way to subdivide yourself. And so this is probably familiar. This is sort of XP sized. I would favor 10 to 12 rather than 20, but So XP sized teams, 10 to 12 people, cross-functional, organized in units of around 160 to 200. So this is Dunbar's number, right? The number of social connections that you can hold in your head at any one point. if you're organized into units like this, it means when I see Kate in the corridor, I can say, hey, Kate, how are the kids? How was golf on the weekend? Rather than Kate being a completely faceless entity who I don't know anything about. And something I'll come back to at the end about ThoughtWorks and our experience. And this is actually how ThoughtWorks started or built most of our offices. So we tend to get to a certain number of people, around about that sort of number, and then we start another office in a different part of the world or a different part of that country. That's why we've got an office in Manchester and one in London, Dunbar's number. It's easier to maintain communities if you're organized in units of that size. It's another interesting piece of research that Martin Fowler showed me some years ago actually now, and it's from this book called Managing the Flow of Technology by Thomas Allen back in 1977. Like, none of this is new, right? None of this is new. So Thomas Allen, back in 77, he did a ton of research into how work worked in R&D departments. Right, how research and development departments in big organizations, how they were structured, and how communication worked. And he found something interesting. See, he found this. This is the key result. So that communication frequency varies with the inverse square of distance. So we've got a graph here showing the probability of me having a weekly interaction with someone on one axis, y, and the distance they are away from me on the x-axis. So if someone's more than about 8 or 10 meters away, maybe, and that includes like flights of stairs, that counts as that's included, I'm never going to have a serendipitous conversation with them. It's just not going to happen, right? This probability shows that. So if you want to sit people, if you want people to talk to one another, sit them close together. If you've got people who don't like each other, sit them further away from each other, right? And the implication of this is if you've got a library, don't put it where everyone's walking through it, because people will be chatting all the time. But again, this is how ThoughtWorks sort of built our offices originally, taking into account Dunbar's number, Thomas Allen's research. So co-locate as much as possible and take advantage of serendipitous conversations. Now, Slack is great, because Slack and HipChat and the others, they reduce this, they reduce the effect of this, but they can't solve for it, right? Because it's the serendipitous things that you can't just have on Slack. So, this is my thesis. As you chunk up from this team to value stream to market segments to your organization, you've got Conway's law to help, Allen's research about distance from people and communication, and then Dunbar's number in terms of organizational units. And these things will help you preserve low coupling and high cohesion of your teams and therefore the software those teams are building, because they are isomorphic with one another. And also remember, whenever work leaves your team, you incur cost. In the home straight now. I might need a better name than this, haha. This is the chunking up from microservices to teams to value streams to market segments to organizations practice onion. I've stated already, right? Software systems are isomorphic with team boundaries. If that's the case, we should be able to use either to reason about the other, right? We should be able to use team boundaries and organizational boundaries to reason about the other. So, you can use organizational boundaries to reason about the cohesion of the software that the teams within those boundaries are building, the coupling of services between them, which testing types to apply, and integration patterns to use. And I'll leave you with some examples. So, between organizations or between large chunks of your organization, there are a set of patterns that allow you to evolve software that you might or might not want to apply. Because applying these things costs money, right? Someone has to do it. Teams have to do it. So an example here is between organizations or between chunks and between the software, therefore, we should probably be thinking about using semantic versioning. So semantic versioning have a well-known method by which you can version APIs. But you probably don't want to do contract tests across these sort of organizational boundaries. So when I say contract tests, I mean explicitly consumer-driven contracts. This is where me, as a consumer of another service, I write an executable test and hand it to that service provider so that they can execute them. So that when they make a change, they know whether they've broken my usage of them or not. That's what contract testing is, consumer-driven contracts. Now, if I'm producing the Google Maps API at Google, I'm offering that, it's externalized to everyone. I don't want every single person who uses the Google Maps API to write a contract test and hand it to me, describing how they use it. That just makes no sense. right? What am I going to run it on? I suppose you could run it on Google, but hey. Between smaller units, you might make different decisions there, right? So between smaller units, you might say, I'll continue to use semantic versioning, but I'll also write contract tests so that I know when someone using me has been broken as I'm developing. But I might also want to say, we'll all implement the tolerant reader patterns. This is an implementation, if you like, of Postel's law. So I don't break on unexpected input, essentially, and I only bind to exactly what I need. The principle of robustness. Similarly, between teams within a single value stream. But within your team, maybe you make different decisions again. So within your team, maybe you rely on conversational change. You decide not to make the investment in contract testing. I'm sitting next to this person. If I'm going to make a change to my API, my service, I can just say, hey, Bob, I'm going to make a change. Can you just update your stuff? Conversational change. But I should still probably implement tolerant reader because, well, if you don't, you're an idiot. Sorry if I called everyone in the room an idiot. This sounds totally crazy, right? No IT, we're just going to have developers sitting with our business people, we're going to organize in these concentric rings. Surely this doesn't happen. We have a number of existence proofs that this works. Right. What I find quite powerful to talk about is my own experience inside ThoughtWorks. Because 5 or 6 years ago, ThoughtWorks was organized classically around technical operations, tech ops, and then our colleagues in our commercial teams, demand, finance, and the underlying systems architecture was an absolute mess. We had like PeopleSoft, Lotus Notes, and someone had heard that ESBs are a bad idea, which is good. So they'd implemented one in a database and called it the middleware database. Not so good. It was a complete mess. And some years ago now, 5 or 6 years ago, we decided that we would move towards this model that I've been describing, towards organization around stable business functions, moving our development teams into those business functions, so that they could deliver value more quickly. So that's what we did. This is a very busy diagram, I apologize, but it's from a presentation one of my colleagues did recently about how we're organized. So we have business functions, so we have a team that supports our sales teams, IT team as part of sales, the development team as part of sales. We have a development team as part of our staffing functions, a big deal for a professional services company, who's going to go onto which project. We have other teams for the other business functions. And then we have other product teams, like site reliability sort of product teams, providing services to those teams as well. So there are other existence proofs. Compare the Market is one. Actually, the Government Digital Service in the UK is another one. They produce YouGov. They provide payments gateway for government. They provide a bunch of other things, identity services. So there are existence proofs of this working, and also every single trading desk at every single bank that you'll ever visit. I'm not saying it's the only way of doing this, I should point that out. So thoughts to finish. Successfully adopting this stuff, microservices, I would argue, requires much more than just componentization. It requires you to think really hard about your organizational structure and how your teams are working. There's this thing I like called the inverse Conway Manoeuvre, which is in the title of this. This is from a colleague, Evan Botcher. He says one of the ways you can go about making architectural changes is to first design the organization you want based around your business needs. And then your architecture over time will follow, kicking and screaming. And some things to look out for. So I think Conway's law sends us signals that we can listen for. So one thing would be if you're consistently having to order work across different teams, in an agile sense. If you're splitting bits of work and having to hand them off between teams. If you're having to move people around a lot, right? Conway's law is sending you a signal. If you're having to deploy everything together, it's a sign you're probably too coupled. And if you have to fan in for end-to-end testing, again, I think that's Conway's law. And finally, high cost associated with work leaving your teams. So if you're raising tickets all the time with a platform team, right, that's going to impede your progress. It's going to slow you down. Handing off work to other departments, order of magnitude increase in cycle time. And if you're constantly having to start and stop projects, that's another high cost. Finally, the last word. So I got an email. I did this talk. This is probably about 2 years old now, this talk. I got an email after I presented it a few times. This is what the email says. It says, "Hello, James. I've recently come across your presentation, Go Faster Than Your Competitors," that was the original title, "and how I finally stopped worrying and learned to love Conway's Law. No, I am not sitting in the balcony laughing. I'm sitting at my computer learning from you, and your depiction of me as a Muppets figure helps to keep me humble. Keep up the good work. Regards, my best Mel." So, I have his official blessing. Thank you very much.